And 9/6 is really not that bad if you see how I'm doing them. So here we go, y'all, 9/6. And it's what? Solving exponential and logarithmic equations. So I'm going to focus on exponential first, and then I'll play with the logarithmic. So first thing I'm writing is my steps to solving exponential. Your exponential equations are the ones that look like a to the x equals y. They've got the variable is the actual exponents on these, okay? So, first thing you want to happen, hopefully, is that you can rewrite each side using the same base. So can we rewrite each side using the same base? So if I can, we got a property that's called the exponent base property. It tells me if a to the x equals a to the y. So notice these bases match on this. If you get the bases to match, then that means the exponents have to be equal. So if I had something like 2 to the x equals 2 to the 4th, since they both got a base of 2, that means the x would equal the exponent of 4, okay? If not able to write using the same base, then I need to figure out how to pull the exponents down.
I'm gonna wait till you finish.
Oh, I'm good, I'm good. Which one?
You gotta fill out a form, I can't figure out what that form is.
Are you talking about for that committee stuff?
Yes.
So go to your portal, go to employees.
Employees.
When you click on employees, on the left side, it'll pull up a list that says surveys and evaluations or something.
Excuse me, student.
So y'all hang on just a second. So let me quit sharing this and get this pulled up. I did that a while ago. It's like you got to list what committees you're on, if you're on any,
Yes.
and if you're on any, you got to put how many years you've been on them, and then
Oh, gosh.
on the bottom of it, it has you. So you're gonna log into this portal. Now, I seen that email, so I did that a while ago. All right, go to this employee tab,
Okay.
and then over here it says evaluation and surveys.
Mhm.
Now mine's gone, but
It'll
what
list
it'll
it?
show it right here. It'll say
Okay,
some kind of survey. Just click on it, and it'll give you a few questions. to do.
okay, thank you.
Okay.
Excuse me, student. Okay. Faculty and then all, okay, got it.
Go to your employee part. Okay.
Yeah, thank you. Okay.
All right. All right. So now, if I'm not able to rewrite them at the same base, which some of these problems we won't be able to, then what we're going to do, we're going to take the log of both sides. Now, if E is used in the problem, then I'll take ln of both sides. It would work if you did a log, but when you got E and you take the ln of E, that becomes a big 1. Ln of E equals 1. So I use ln, it makes these problems easier, okay? Only if I got that little E in my problem. All right, so what happens when you take the log of both sides? Then, using the power rule, I'm going to bring the exponent down. Or what? Bring exponent to the front and write it as a product. But we did have a lot last week when y'all was in here. My last step on a lot of them problems, I was like, what's the last step? It was bring them exponents down in front of them logs, okay? After that, solve for the variable. And then like last step on any equation, if you want to, check them answers, okay? Especially on the log equations. So we're going to start out doing some exponential. You know, all these will say is solve for x. And I'll sort of number them like they're numbered on your homework, so I should be able to get most of these done now. So number one, I got 6 to the x equals 36. So my question would be, can you write 36 using the 6 and raising it to an exponent? And that's true, right? I can do that. So what I'm going to do, since I know I can rewrite 36 using the 6, I'm going to rewrite 36 as 6 to the second power. Y'all with me? So that gives me what? 6 to the x equals 6 squared. So I can actually use this first property, which says if I got two bases that match, then that means those exponents have to be equal. So here we go. Bases match. So x equals 2. And we're done. So some of these equations are a lot nicer than those ones where y'all have to factor and do all that, okay? So questions on that. So the trick is, can you rewrite these numbers, okay? So I'll do another one where we can rewrite them. How about 4 to the 5x equals 16? So the question would be, can you rewrite 16 using a 4? And we definitely can rewrite 16 using a 4. I can rewrite 16 as 4 squared, right? So I would get 4 to the 5x equals 4 squared. All right, bases match. So since my bases match, I know that this 5x has to equal this 2. So my exponent's got to be equal when them bases match. We got one step and I'll be done with that. I need this to be an x. So I'm going to divide both sides by 5. So that x equals a 2/5. Okay. So I love the exponential equations because if you can rewrite them, just solve that exponent, okay? But guess what? Sometimes you cannot rewrite them. So number 3. Question? Oh, I thought I heard something. Did y'all not hear something? What did you say? You're playing games. All right, y'all. 5 to the x equals 24. So can you rewrite 24 using a 5? Well, 5 to the first is 5. 5 squared is 25. So there's no way I can take that 5 and rewrite it. I mean 24 and rewrite it using a 5. So I cannot rewrite. So since there's no e on this, I'm going to take logs of both sides. All right, so I'm taking the log of both sides. So the log of 5 to the x will equal log of 24. And the whole reason I did that, because now, since I rewrote it as a log with an exponent, I can now pull the exponent down to the front and rewrite this as x times log of 5 equals log of 24. That's why I was playing with that last week so much about the exponents being pulled down. All right, so x times log of 5 equals log of 24. I need that x by itself. So I will divide both sides by the log of 5. So y'all, if you want to get this right, when you do these logs, it's going to give you a parenthesis. You got to close that parenthesis on the 24 before you hit the division, and then put that log on the bottom in parentheses also, okay? But once you hit this log, it's going to give you one parenthesis, put in the 24, then close them. If you don't close them, it's going to give you some kind of wild answer in there, okay? Now these, we won't round it out 4 decimal places. So if I divide log 24 by log 5, I get x equals 1.9746. Okay. So you like it when you can rewrite them, but if not, take those logs and bring them exponents down. That way we can actually solve for them exponents. And that's why Isaac Newton invented logarithms, so we can solve for variables when they are those exponents, okay? All right, this will be like number 4. 3 to the 9x minus 5 equals 81. You know, I'll tell you a trick on this. If you want to, start with 3 and just keep multiplying 3 times itself and see if you can get 81 out of that. If not, then you know you can't rewrite it. But this one you can. I will rewrite 81 using a 3. And that'll be 3 to the 4th power. 3 times 3 is 9, then you get 27, then you get your 81. So we get 3 to the 9x minus 5 equals 3 to the 4th. So y'all see what's going on now. My bases are going to match. So since the bases match, I know that 9x minus 5 has to equal the 4. All right, y'all, I'm going to solve that for the x. So what we're going to do, what? Add the 5 over, and then we'll divide by that 9. So this will give me 9x equals 9 divided by 9. I get what x is, 1. So to check this, I'll just put this 1 in for that x. 9 times 1 is 9, minus 5 is 4, and then 3 to the 4th power does equal 81. So any questions bugging y'all on those so far? All right, so let me try this one. How about, this is like number 5. 3 to the x equals 5. So I don't think I can rewrite that 5 using a 3, because 3 to the 1st is 3, 3 squared is 9, so that's going to work. So cannot rewrite. So take logs of both sides. So I got log of 3 to the x equals log of 5. You know, all this goes back to equations. What you do to one side of those equations, you're doing to the other side automatically, right? So guess what I'm going to do now? I'm going to take that exponent and bring it down, just like I did on that problem. That's the whole reason I do the logs, so that I can bring the x down to the front and write this as x times log of 3 equals log of 5. You'll notice these problems, they're matching each other all the way down. On that point next, I divided by the log 3 stuff, so I'm going to divide both sides by log 3. And usually they want these around 4 decimal places, okay? So let's see, log 5 goes in parentheses. And then you're going to divide that by log 3. So this is what, number 5. So on that, and I got 1.4650. That what you got? Yeah, they're just rounding that 4 because of that number behind it. Questions on those yet? So let me do the E. Remember I said I can do the E. When I do the E, I'm going to do an LN instead of a log. So this is like number 7. Now the ones I'll skip, I'll get them at the end, okay? So number 7 has e to the t equals 153. Now back in the 80s, they used to make fun of these e's and the t's. They would say phone home. Y'all remember that? E.T. So y'all ain't too young for E.T. That was like 85, 86, 87, somewhere around there. He's a little alien dude. Oh, okay. So guess what? I'm not even going to try to rewrite 153 using the E as a base. Probably not happening. So I cannot rewrite. But since that's the E, I'm going to take ln of both sides. Now it would work if you did the logs, but it'd be a lot more work to do. Okay. Now here we go. ln of e to the t equals ln of 153. All right, so I did that. The only reason is so I can bring that t down and write it down here as a product. So I get t times the ln of e equals the ln of 153. So one of y'all ask your calculators, what's the ln of e? Because remember, ln is really a log base e. So this part right here, ln of e equals 1. So basically, that just gives me t equals the ln of 153. So if you take the ln of the e, basically you end up with whatever that exponent was, okay? All right, so let's see, what is the ln of 153? I got my ln on the front of here, so let's see, ln 153. So I'm getting t is approximately, and really when you're using, I'll put equals, but when you're estimating decimals, the squiggly means you're approximating them. So I probably should have used squigglies there, but oh well. But I'm getting a 5.0304. And then since there was a 3 after that, we had to round that up, okay? So E, use the ln. All right, let me see what I did after that. All right, so I'm gonna do some of the log ones, that way I can make sure I get the logs done, and then I'll go back and I'll skip a few, I'll catch them up, okay? So next will be steps to solving logarithmic equations. First thing you got to do, combine any logs on either side. So if they're being added on one side, you write them as a product and they get multiplied. If they're being subtracted, you write them as a quotient and they're being divided. Do we have log bases that match on each side? If I have log bases like a log of 2 on one side equals a log 2 or something on the other side, then I'll use what we call the log base property. And it's sort of like the exponential base property I did a while ago, which says if log A, oh, let me pull this down. If log base A of m equals log base A of n, so if the logs match on each side, then m will equal n. So just like that base exponent, this one you're looking for the logs to match. And they're going to have the same bases in the homework, so don't worry about that. But if you get a log on one side equal to a log on the other side, then that means these results are equal. If I do not have logs on both sides, then I will rewrite it as exponential. And at that point, solve for that variable. Now, on these, I'm more picky than I was on these exponential equations. On a logarithmic equation, you better check them answers. And the reason is, I cannot take logs of negative numbers. So if you're trying to do like a log of -2 or something on the calculator, you better get an error message on that. Because there's nothing I can do to any number to turn it into a negative number, okay? So some of these at the end, you'll be factoring to get the answers. Those negative answers, you're going to kick them out and only keep the positive answers, okay? All right, so here we go. Let's start some of these log equations. Oh, these are starting at, looks like number 10. I want to solve log base 4 of x equals 2. So really on that one, I don't have any logs to combine. I don't have logs on both sides, so I can skip that. I'm down to this step. If I don't have logs on both sides, it says rewrite it as exponential. So the base is 4. So you bring down the 4. The exponent is the 2. And 4 squared is going to equal the result of a x. So remember, y'all did this in like section 9.3 or 9.4 when you had to rewrite it. Well, the only thing to finish this out is what is 4 squared? 16. So I get 16 equals my x. I'm telling you, some of these you're going to love, some of these you'll probably hate. How about this one? Log x equals -5. So there's not logs on both sides, so I'm going to rewrite this one as exponential. So let me write that here. I'll have to rewrite as exponential here. So I'm going to do the same thing here. I'm going to rewrite as exponential. Oh, there's only one problem. There's not a base shown down there by that log. One is the base when there's not a number right here. 10. Remember, that is like a 10 sitting there. Well, I'm getting through this somehow then. All right, so here we go. I got 10 to the -5th exponent is going to equal my x. So let me see. I think if you just place that in 10 exponent -5, and might give me 1 to the e -5. That means that this is a 0.00001. I think MathLab will take it as a 10 -5. I'm not real sure. But if you're missing that, just let me know and I'll sort of look at them. So -5, watch this. You start from the decimal. 1, 2, 3, 4, 5 places over, okay? If that's a 4, I'd have 3 zeros and then more. All right, so I'm going to skip 12 a second because I want to do this 13. Are you on the actual homework page? Are they matching what I'm doing sort of? Other than the numbers? Okay. So 13, I have a log plus a log. So I got a log x plus a log x minus 21 is going to equal 2. So I do have logs on the left side that can be combined. So we're going to combine these logs. Since they're being added, we rewrite this as a product. So it'll be a log x times x minus 21 is going to equal 2. And I'm actually going to multiply that before I rewrite this, okay? And I'm just going to distribute that x through here. So I'm going to get a log x squared minus 21x equals 2. So if this was being subtracted, I'd have wrote that as division, okay? But they're being added, so we rewrote them as multiplication. All right, I don't have logs on both sides, so that means I'm going to rewrite as exponential. Uh-oh, no base, so it is a base here is 10. So I got 10 to the exponent 2 is going to equal the result of an x squared minus 21x. And just remember, that was a 10 down there. So the trick on this is just remember this number over here is the exponent, okay? All right, so what's 10 squared? If I got 100 equals x squared minus 21x. All right, you got x squareds in this one. So that means everything needs to be on one side equal to 0. So I'm going to subtract my 100 from both sides. And I get 0 equals x squared minus 21x minus 100. So, don't get to factor this now. Or if you don't like factoring, hit it with the quad. Quad will give you two answers, okay? So I got an x and an x. That's negative, so you got a positive and a negative. Factors of 100, that'll give me 21, would be 25 and 4. But remember, I got to set both of them equal to 0 to solve them. But remember, when you solve them, all you're doing is changing the signs of these. So I'm going to set x plus 4 equal to 0, x minus 25 equals 0. So let's see, the first one I'm going to subtract 4 from both sides. I get x is a negative 4. Second one, I'm going to add 25. And I get x is a positive 25. But you better check them answers. Because you got a log x here. You put that negative 4 in for this log x, it's going to give you an error message. So try to take a log of a negative 4. Put that on that calculator, log negative 4. Hopefully you get an error message. Something about non-real answers or something like that. Yeah, so anytime you get these negative answers on a log equation, you're going to kick them out. Because you can't check them. Which means the only answer is going to be 25. Okay? So you'll notice that when you're doing these log equations, you're going to usually get two answers. One's positive, one's negative. Kick out that negative one, okay? So, trick on this one was really just turning it into one log. What's that, 14? How about 3 logs? I put logs everywhere. Log base 3 of t plus 16 minus log base 3 of t plus 7 equals log base 3 of a t. And I think the other thing I like about these log equations is they go through other equation types that you got to remember, okay? Like this one, you had to remember, solve it by factoring on the quad, okay? All right, we got 2 logs on the left side. We're going to combine these into one log. So they'll both be log base 3. Since this is being subtracted, we're going to write it as a quotient. Positive part's on top, which is a t plus 16. The part being subtracted goes to the bottom, which is the t plus 7. And then my right side's still what? Log 3 of t. But I got a log base 3 on both sides. So the log bases match. since a log basis match, I know that t plus 16 over t plus 7 is going to equal t on the right side. So it's been a while maybe since y'all solved a fractional equation like this. So I'm going to tell you what I'm going to do. I'm going to put a 1 under that, make it look like a fraction. And I'm going to cross multiply this stuff. Cross multiplying, those two multiply together, equal to those two multiplying together, okay? So watch this. T plus 16 times 1 is t plus 16. Well, we're worried about the other product. T plus 7 times t. You got a t times t, which is a t squared, plus 7 times t is a 7t. So you'll see what's going on. I got another t squared in this, right? So since I got a t squared, all this has to be on one side equal to 0. So I'm going to minus a t and minus the 16 from both sides. Okay. So let me come back up here. So minus and gives you a 0 on one side equal to t squared. Let's see what I got. 7t minus 1 leaves me a 6t. And then at the end was my minus 6t. At this point, you can hit it with the quad or factor. Now, to tell you the truth, I usually factor all these for y'all just to get y'all better at factoring. But you can put it in quad. Or even you got factor programs, you can hit factor program and get it factored if you wanted to go that route. But it's a t and a t, that's negative, so one's positive, one's negative. Factors of 16, that'll subtract to give me 6, would be 8 and 2. So let's see, positive in the middle, 8 is positive, 2 is negative. And then y'all set both of these factors equal to 0. Woo, I'll be glad when we go back to normal. It is hot with all this hot breath being in the face. Woo, okay. So I get t equals -8, and then on that I'll add 2 and get t equals a positive 2. Am I going to keep both them answers?
No.
No. That negative one, if you try to take a log of a negative number, it's going to give you an error. So kick out the negative answer and only keep the positive one. Okay? So notice some of these, once you get to the part where we solve the equation, they're a little longer than some of these others, okay? Still, this has to be a little better than trying to spoil about 3 or 4 things, right? So 14, let's see, what's next, 15? So questions on anything at the moment on this problem. Bring back memories from the whole year almost, though, you know? All right, there we go. 15. Log base 4 of x plus 1 minus log base 4 of x equals 3. I'm going to combine the logs. They're being subtracted. So they're going to look like division. Okay? So same thing here. I wrote it as the quotient. So this would be a log base 4. X plus 1 on top over, since this is being subtracted, the x goes on bottom. And all that's going to equal 3. So at this point, you don't have logs on both sides. So we will rewrite this as exponential. And that's the main thing I want y'all to see. When do you rewrite them as exponential, and when can you use that log-based property, okay? So like this one, I was able to use log-based property. I had logs on both sides. This one, I'm going to rewrite as exponential. My base is 4. My exponent is 3. And that's going to equal x plus 1 over x. So before I do anything, I'm going to figure out what is that 4 to the third power equal. So that'd be 4 times 4 times 4. We in Arkansas, that takes us a little while. 64. 64? So 64 equals x plus 1 over x. And the reason y'all have troubles on that is because Arkansas, we put it 12 times 12. Y'all never do like 16 times 4 type stuff here.
Dude, from Texas.
You from Texas, y'all do 13s? So everybody knows what 12 times 12 is. It's usually what separates us. We're down here fighting with Mississippi to see who can be on the bottom of the education train, you know, trying to decide if we want to move to the 13s and work them or what. You know, I tell you, the part that kills people in algebra is they can't factor because they don't know the factors that make these numbers up. You know, like 24, everybody knows 12 times 2, 6 times 4, but they forget 8 times 3 and stuff like that, you know, so that's what hurts people. So if we could just make y'all multiply every year from 3rd grade on, be better at factoring, I think.
If you get it at a young age.
And quit worrying about the little, what time does the clock show you? It's all digital now. Don't know what time is on the clock anymore no more. You know? I guess what? I'm going to put a 1 under the 64, and I'm going to cross multiply this just like I did a while ago. So 64 times x is a 64x. 1 times x plus 1 is an x plus 1. All right. We need the x's on one side equal to the number. So I'm going to subtract an x from both sides, and I get 63 x's equals 1. And then divide both sides by 63. That cancels. X equals. Well, you can't reduce that no further, can you? That's just going to stay 1 over 63. Now, I'll tell you what kills people on that problem. They treat that 1 over 63 like a 63 over 1. And they turn it into a 63. MATLAB says big red X. 1 on top stays on top, okay? All right, next is 16. So I'll do 16 and then I'm going to sort of step back and get some of them exponential ones out. Skip them all, okay? All right, 16 has log base 3 of x plus log base 3, x minus 1 is going to equal log base 3 of 6. Now, I will tell you, if you wanted to bring that log 3, 6 on the other side, you could and still work those, but it's a lot longer process to do that. So I'm just going to keep y'all with doing log equal log stuff. But you got 2 logs over here, so we're going to combine logs. So that'll be a log base 3. X times x minus 1 is going to equal log base 3 of 6. Since they're being added, we multiply them, okay? And before we rewrite this, we're going to distribute that. So log base 3 of x squared minus an x is going to equal log base 3 of a 6. But I got logs that match on each side. So the log bases match. Since the log bases match, I know that the x squared minus x is going to equal 6. So subtract 6 from both sides because you got these x squareds on this one. Doing that, I get an x squared minus an x minus 6 equal to 0. So look, this is like the 4th or 5th one where you've had to factor these answers or hit them with that quad, okay? So x squared is an x and an x. That's negative, so we've got a positive and a negative. So what factors of 6 might equal a 1? Only got 2 guesses. It ain't 6 and 1. Well, what other way can I multiply getting a 6? 1 times 6 works, but that don't work on this.
2 and 3.
What you got?
2 and 3.
2 and 3, okay. Saved by the own line. 3 is bigger, is negative, and the 2 will be positive. Y'all must be all hitting that quad. All right, y'all set both of them equal to 0. So I get a negative 2 and a positive 3. But remember, this is a log equation. When you put a log of negative 2 right here, it's going to give you an error. So we cannot keep the negative answer. And the only answer is 3. Okay? And that's just because that one log right there. And y'all can even punch that log base. Remember, go to math and go down to log base. If you punch in a base of 3 and put a negative 2 in there, it's going to give you the same error messages, okay? All right, so let me sit back and we skip number 6. I'm going to do number 6. So see if your number 6 has some negative exponent on it. Mine's like 10 negative x equals 8 to the 5x. Is yours sort of similar?
I'm trying to get back to, it's not really,
What is it?
it's just, it's not.
Or internet? Okay, so good, they did take off the 9-7. I was hoping it would remove that one. All right, so I'm back to the exponential equations. So exponential, I can't rewrite these at the same base because one's a 10 and one's an 8, so there's no way to rewrite that. So, can't rewrite with same base. So I'm going to take logs of both sides. So the log of 10 to the negative x will equal log of 8 to the 5x. And I'll tell you, this one don't look bad, but it's one of the trickiest problems on here. All right, so I took logs so that I could bring my exponents down to the front. So I'm going to do that on both sides. So this side will give me negative x times the log of 10. That's going to equal that side, which is a 5x times the log of 8. Notice, so I got x's on both sides. So since I got x's on both sides, I'm going to try to pull everything on the same side. So I'm going to add x log 10 to both sides. So this side is definitely gonna give me a 0. But y'all guess what? Those ain't like terms, so they won't add together. So you're gonna have 5x log A plus x log 10. So I would probably get 5 bonus points if someone can tell me how to turn them 2 x's into 1x. Because those sure ain't like terms. And I gotta solve it for that x sitting in there. All right, so now I'm getting my bonus. The only way to pull these x's out would be to factor them out like a GCF. So y'all watch this. I'm gonna factor the x out like a GCF. Because both of them have an x in them, right? So my GCF will be the x. Inside the parentheses will be 5 log A plus log 10. Okay? So when you got an x in 2 or 3 terms and you need to factor it out, you gotta pull it out like the greatest common factor, okay? And that's because these won't add together. All right, so check this out, y'all. There's a little property I got called zero product rule that says if 0 is your answer, I got one of these got to equal 0, and it ain't that, so that means that x probably going to equal 0 when I'm done, okay? But to show you, I'm going to divide both sides by 5 log 8 plus log 10. And then this side, x times 5 log 8 plus log 10 divided by the 5 log 8 plus log 10. So I'm going to cancel them. I now have x by itself. And I'm not going no further because I know 0 divided by anything is 0. Okay? I bet your number 6 is going to equal 0 too. Because these problems just don't change much. And since they're, but 10 to the 0 equals 1, 8 to the 0 equals 1. Anything to the 0 power equals 1, okay? So let's do 8. I skipped 8 while ago. And 8 has the E on it. So since it's got the E, I'm going to use the LN on this one, okay? So I got E negative 0.87T equals 0.89. I'm not going to try to rewrite that 0.89 using the E. I don't even know if it's possible. So, can't rewrite. And same basis. So, I'm going to take ln of both sides. E has ln, because when I get down to the point where I got an ln of E, I know that equals a 1, okay? So ln of E to the negative 0.87T is going to equal to ln of 0.89. Next, bring your exponent down to the front. Times the ln of E equals the ln 0.89. All right, but remember, we said ln of E equals 1. And we know that because if it equals 1, we can basically get rid of it. So that'll give me a negative 0.87T equals the ln of 0.89. And y'all, one more step to get that T by itself. I'm gonna divide both sides by negative 0.87. Oh, yeah, okay. And then that'll equal this side ln of 0.89 divided by negative 0.87. So when you do that, make sure you close the parentheses on the ln 0.89. We're gonna round that out for decimal places. So this one looks like I'm getting a 0.1339. Now, the reason the computer's using the curvy parentheses, anytime you're estimating decimal places, I use the curvy ones because it's not exactly equal to that, you're just estimating it. All right, so some of these are trickier. It just depends on what they got sitting up here as these exponents, okay? I know I skipped another one in here. I don't think I did number 9. Six to the x equals 3 to the x plus 1. Well, can't rewrite those bases to match. So I'm going to take logs of both sides. So since I don't have the e, I'm going to take the logs. So I can't rewrite. So I'm going to take log of both sides. So the log of 6 to the x equals log of 3 to the x plus 1. So we're going to shoot some exponents down to the front. So I get a x times log of 6 equals x plus 1 times my log of 3. So let me tell you a trick what I'm going to do to this. I'm going to rewrite these by distributing my log to both of those, okay? So I'm going to get an x log 6 equals x log 3 plus log 3. So guess what? The x's need to be on one side here, right? So since my x's need to be on one side, I'm going to subtract x log 3 from both sides. So I'm going to get an x log 6 minus an x log 3 equal to a log 3. So I shall ask y'all again, how can I take both them x's and turn it into one x?
Greatest common factor.
Same thing I did on number 6. All right, what are y'all saying on here?
Oh, the greatest common factor.
Greatest common factor again, because both of them have an x in them, right? So we're going to factor out the x as the greatest common factor. That'll give me a log 6 minus a log 3, all equal to a log 3. That's why I say this until last. It's got a lot of tricky stuff on it. Well, x times all that equals log 3. I'm going to divide both sides by all that. I'm gonna divide both sides by by log 6 minus log 3. That's going to equal this log 3 divided by log 6 minus log 3. Now let me tell you what you got to do on this one. You got to close these parentheses on the 3 before you divide. Once you hit that division, you got to make big parentheses and put this whole bottom in parentheses. Then do your log 6, close parentheses, minus log 3, close parentheses, then close your big parentheses.
Oh, wow.
Since you got more than 2 things on the bottom, it's all got to be in parentheses, okay? So that's number 9. So let's see, what did I get on number 9 when I shot that to? I get x is approximately 1.5850. So I'm pretty sure y'all, I think there's only one I ain't done, and it's the very last one. So I'll do number 17 real quick, and that'll be all of them, okay? Don't just show me 17.
I'll watch that in a minute.
Oh, you're gonna do that? Okay. I think there's only 17 for y'all. But that's it, so let me hit this one. Hang on, here we go, 17. What's that say? TV, idle, standby? What's that mean? All right, hang on, let me fix this TV real quick. Volume. Okay, I should be good. I ain't never had to do that, did you? I guess I've had it on a couple hours now. Probably a 4-hour time limit on it or something. All right, there's gonna be logs again, so this very last problem. So log 3 of x plus 12 plus log 3 x minus 12 equals 4. So I'm going to combine logs on the left side. So that'll give me a log base 3. Remember, these are being added, so there'll be a product, x plus 12 times x minus 12. All that's going to equal 4. I'm going to pull this real quick. These are conjugate pairs. X plus 12, x minus 12. They're exactly the same underneath the signs. So I will shortcut this and do x times x, which is an x squared, minus, 12 times 12. See, Arkansas knew that, Texas didn't. All equal to my 4. I used to get dragged on Mississippi. I'm going to get dragged on Texas. All right, I'm going to rewrite this as the exponential because I don't have a log on both sides. All right, my base is 3. My exponent is the 4, and that's going to equal the x squared minus 144. So what is 3 to the 4th power? Go ahead earlier.
81.
What did I say?
81.
81, there you go. So I got 81 equals x squared minus 144. So x squared, so I just want to shoot that 81 to the other side by subtracting. All right, if I get a 0 over here, x squared minus 144 and 81 give me what, 225, I think. So if you quad that, it's got to be 1, 0, negative 225. There's not an x in the middle, it's got to be a 0, okay? But y'all, I'm going to factor this. X and the x, last one's negative, so one's positive, one's negative. Hey, what's the square root of 225? Hey, we don't know that Arkansas either. That'd be good 12. But you got that blue radical on the left side. So hit your blue button and then that radical. What the x squared button is. Oh, it's got a perfect square root. So let me see. Oh, no, 15, you done did it. You should have said 15, man. 15 and 15. Anytime you get an x squared minus something that's perfect squares, just take the square root of that number to get your numbers, okay? So then let me finish this out by setting them equal to 0. So minus 15. And then plus 15. Will I keep both them answers?
No.
No. Because if you put that negative 15 here, negative 15 and 12 is a negative 3. I can't take the log of a negative number. And then this one had to be some number bigger than 12 to keep it from being negative, right? Which was my 15. So once again, we cannot take the negative answers, and we're only going to keep that positive one. Okay. So we all have 9-6. So I think we've done every question on there. So Wednesday, I will review for test 4. I think test 4 had 25 questions, but a lot of them are just punching logs on the calculator and stuff. So we'll do that Wednesday, and then, like I said, Monday is final exam review day, okay? And y'all just have one more week, man. And then y'all be moving on to what's next for y'all, calculus, statistics, sciences. No, there's not. I got to tuck my in here. All right, y'all. So we'll end this, and I will see y'all